In this presentation, we have to derive an expression for eigenfunction of hydrogen atom. For that, consider the equation. Already we have arrived at this relation. Rho square g 2 dash of rho plus rho into 2l plus 1 minus rho into g dash of rho plus lambda minus L minus 1 into G of rho equal to 0. So this is a relation you have had in the previous lecture. While deriving energy eigenvalue, we arrived at this relation. In this relation, replace lambda by n. Already we have proved the value of lambda equal to n. Then consider this term 2 into L plus 1, which is equal to 2L plus 2. Put P equal to 2L plus 1. Therefore, 2 into L plus 1, which is equal to P plus 1. Then take the term. If you substitute lambda equal to n in equation 1, this is modified as n. This is lambda, write down as a separate equation. Rho square g 2 dash of rho plus rho into 2 into L plus 1 minus rho g dash of rho plus n minus L minus 1 into g of rho equal to 0. See, this is equation 2. Instead of 2 into L plus 1, we have to put P plus 1. Then take this term n minus L minus 1, which is equal to n plus L minus 2L minus 1. See here, n plus L minus 2L is n minus L minus 1. This is equal to n plus L minus of 2L plus 1. If you take this negative sign outside, this is written as 2L plus 1. These two terms are presented as 2L plus 1. Say this is n dash. 2L plus 1 is our P. Here n plus L is taken as n dash. Put n plus L equal to n dash. Therefore, n minus L minus 1 equal to n dash minus P. Now, the equation 2 is modified as rho square g 2 dash of rho plus rho into P plus 1 minus rho g dash of rho plus, instead of this we have to put n dash minus P into g of rho equal to 0. Say this is equation number 3. Now we have to write the solution for this equation 3. The solution is expressed in terms of associated Laguerre polynomial multiplied by a constant multiplied by a constant, say C. Now the solution is G of rho, which is equal to some constant C into Laguerre polynomial 2L plus 1 of rho. This is a solution for equation 3. You know the value of R of R. We know that R of R equal to e power minus rho by 2 into f of rho. Already I have presented this value. But f of rho equal to rho power s into g of rho. But we have proved that s equal to L. Therefore, f of rho equal to rho power L into j of rho. But j of rho is c into Laguerre polynomial. Therefore, the value of R of R, radial wave function, is equal to e power minus rho by 2 rho power L c into Laguerre polynomial. So this is equation number 5. Now we have to multiply the value of c, the constant value, using the normalization condition. The normalization condition is RNL star of R, RNL of R square dr equal to 1. Here there is NL, N is the principal quantum number, L is the orbital angular momentum quantum number. Say RNL of R is this much, Rn L star of R equal to e power minus rho by 2 rho power L c star, then the same Laguerre polynomial. If you multiply these two things, you can get c square, c into c star, c square integral e power minus rho by 2 into minus rho by 2 minus rho power L into rho power L, rho power 2L, then this polynomial square into R square dr equal to 1. This is the normalization condition. Now we have to replace this R square and dr. You know that rho equal to 2 alpha r. Then lambda equal to mu z square divided by h cross square alpha. This is the value. We have substituted lambda equal to mu z square divided by h cross square alpha while deriving the energy eigenvalue. From this, alpha equal to mu z square divided by h cross square lambda, which is equal to mu z square divided by h cross square n, because lambda equal to n. We have put that same. Now, rho equal to 2 into alpha, that is mu z square divided by h cross square n into r. This is the value of rho. Now we have to find out the value of r. Now we have to express the h cross in terms of h by 2 pi is rho equal to 2 mu z square divided by n into h square. H cross is h by 2 pi. This is 4 pi square into r. There is 2 zr by n mu 4 pi square e square divided by h square. Verify. 2 z r by n. 4 pi square mu e square divided by h0. Now we have to introduce a new concept, Bohr radius, that is a0 equal to h square divided by 4 pi square mu e square. The Bohr radius a0 equal to 4 pi square mu u square, h square by h square divided by 4 pi square mu e square is a Bohr radius. Now the above equation becomes rho equal to 2 zr by n. This is 1 by a0. Because a0 equal to h square divided by 4 pi square mu e square. So this is 1 by a0. 2 zr divided by na0 is the value of rho. From this, r equal to n a0 divided by 2z into rho. Then dr, which is equal to n a0 divided by 2z into d-rho. Now we have to substitute all these values in this equation. 6. Now we have to substitute the values. Is c square e power minus rho power 2l, then Laguerre polynomial square, then the value of r square is na0 divided by 2z whole square into rho square, then dr is na0 divided by 2z into d-rho. Then this is c square na0 by 2z whole cube. See here, na0 square, na0 by 2z, na0 by 2z whole cube, integral, this entire is equal to 1 because normalization condition. E power minus rho power 2l, Laguerre polynomial square, rho square d-rho equal to 1. Say this is equation number 7. Just you have substituted the values of r square and dr. Now this is the standard integral. You have to substitute this itself. Is c square na0 divided by 2z whole cube. This integral value is 2n into l plus l factorial cube, 2n into n plus l factorial cube divided by n minus l minus 1 factorial. This is the integral result, standard integral. 2n into n plus l factorial cube divided by n minus l minus 1 factorial equal to 1. This is equation A. From this we have to find out the value of C. From this we have arrived at the value of C. C square is n minus L minus 1 factorial by 2n n plus L factorial whole cube into 2z by na0 whole cube. Then C equal to root of this quantity. From this we arrived at the value of C. Now Arnold of R, which is equal to e power minus rho by 2 rho power L C into L of n plus L 2L plus 1 of rho. This is the value of Arnold of R. Now we know the value of C. Then C value is n minus L minus 1 factorial divided by 2n into n plus L factorial whole cube to 2z by na0 cube inside the root. This is the value of C. Then e power minus rho by 2 minus rho by 2, then rho power L into the polynomial Ln plus L 2L plus 1 of rho. Say this is equation number 10. This is Arnold of R. Verify this. You know that rho equal to 2zr by na0. Rho equal to 2zr by na0. Now the above equation is modified as Arnold of R, which is equal to n minus L minus 1 factorial divided by 2n into n plus L factorial whole cube 2z divided by na0 cube inside the root e power minus rho by 2, that is e power minus zr by na0, because rho is 2zr by na0, this is minus rho by 2, so minus zr divided by na0, then rho power L 2zr divided by na0 power L, then Laguerre polynomial. The value of rho is 2zr divided by na0. So this is equation 11. This is the value of Arnold of R. From the equation 11, we may find out the radial wave function. Suppose n equal to 1, the value of L is equal to 0, because for the given value of n, L can have 0 to n minus 1 values. Here n equal to 1, automatically L equal to 0. Now we have to find out R1 0 of R. R1 0 of R. N equal to 1, L equal to 0, which is equal to root of, put n equal to 1 minus L equal to 0 minus 1 factorial divided by 2, then n equal to 1, 2 into 1 plus L equal to 0 factorial whole cube 2z divided by n equal to 1 a0 whole cube e power minus zr divided by a0, because here n equal to 1. then into 2zr divided by a0 L equal to 0. Then this polynomial L of n plus L 2L plus 1 of 2zr divided by a0. This is modified as, see here, 1 minus 0 minus 1. So these are all 0. 0 factorial 1. 1 minus 1 0. This is 0. 0 minus 0 0. 0 factorial 1 divided by 1 plus 0 0. 1 plus 0 1. 1 factorial 1. 1 cube into 2. 1 by 2. Here 2z divided by a0 whole cube. The root is include covering this term also. 2z divided by a0 cube root. Here e power minus zr divided by a0. Then 2zr by a0 or 0 is 1 into this polynomial L of n plus L 2L plus 1 of 2zr divided by a0. Now we have to find out the polynomial value to get the R10 of R value. Now we have to write the value of polynomial. This Laguerre polynomial value is summation over k equal to 0 to n minus l minus 1 minus 1 power k plus l. Here n plus l factorial whole square rho power k whole divided by n minus l minus k minus 1 factorial 2l plus 1 plus k factorial into k factorial. This is a standard relation. The value of this Laguerre polynomial is this much. Now we have to substitute the value of n and l in this equation to get the value of this polynomial. Now we will operate. In this equation, we have to find out the value of this Laguerre polynomial by substituting k equal to 0 because the lower limit is k. The value of k, this is the summation, k is varying from 0 to n minus l minus 1. In our case, the value of n is equal to 1. N is equal to 1 means automatically l equal to 0. In the case n equal to 1, automatically the value of l equal to 0. So the k is varying from 0 to n minus l minus 1. N equal to 1, l equal to 0, minus 1. 1 minus 1, 0. So the value of k is 0 alone. In this equation, put the value of k equal to 0, l equal to 0 and n equal to 1. This is equal to minus 1 power, put k equal to 0, 0 plus 0, l is also 0, 0, then the value of n equal to 1. If n equal to 1, automatically l equal to 0, then factorial square. Here rho power k, rho power 0 whole divided by n is equal to 1, l equal to 0, k equal to 0, minus 1 factorial. Here 2 into 0, L equal to 0, plus 1, plus the value of k is also 0, entire factorial, into 0 factorial. The value of k is 0. See, minus 1 power 0, 1. 1 plus 0, 1. 1 factorial. 1 square, 1. Rho power 0, 1. This is equal to 1 divided by 1 minus 1. 0 factorial. 0 factorial, 1. 2 into 0, 0. 0 plus 1, 1. 1 factorial, 1. 0 factorial, 1. So 1 by 1, which is equal to 1. So the value of this Laguerre polynomial for the condition n equal to 1, L equal to 0 is unity. Therefore, we may discard that term. Say the value of Laguerre polynomial is 1 for this case. For this case, this value equal to unity. Therefore, R10 equal to 1 by 2, then this is 2z by a0 power 3 by 2 e power minus zr by a0. This is value of R10. So in the above equation, consider this 2 power 3 by 2. This 2 power 3 by 2 is actually 2 cube power 1 by 2. 2 cube is 8. That means this is root 8. 8 power 1 by 2, root 8. Root 8 is modified as 2 into 4 inside the root. Root 4 is 2. So 2 root 2. This 2 power 3 by 2 is written as 2 root 2. 2 power 3 by 2 is 2 root 2. Then z by a0 power 3 by 2 e power minus zr divided by a0. This root 2 cancelled out. So the value of R10 is 2 into z by a0 power 3 by 2 e power minus zr by a0. This is the value of R10. From this R10, we may get our ground state eigenfunction psi10. See, psi1 0 0 is the ground state wave function. The wave function is psi nlm. Psi nlm is r of r, then theta of theta, pi of pi. This is the value of psi nlm, eigenfunction of hydrogen atom. If you put n equal to 1, L equal to 0, automatically m equal to 0. Then psi 1 0 0, which is equal to R10 of R into y Lm of theta comma pi, spherical harmonics. Here the value of L equal to 0, m is also 0. Now, in order to find out y 0 0 theta pi, we have to use our theta equation and pi equation. See, this is equal to R10 of R, y0 0 of theta comma pi. This is the ground state eigenfunction of hydrogen atom. Now, the theta equation is known to you. Theta is BPLM of cos theta. Then pi equation is also known to you. 1 by 2 pi e power im pi. With the help of these two, we may arrive the value of y0, 0 of theta comma pi. For that we should know the value of b. The constant b equal to 2l plus 1 by 2 into l minus m factorial divided by l plus m factorial inside the root. This is the value of b. In our case, n equal to 1, l equal to 0 and m equal to 0. b equal to root of 2 into 0 plus 1, 1 by 2. Then 0 minus 0, 0 factorial, 1. 0 plus 0, 0 factorial, 1. So the value of b is 1 by root 2. We know that theta equal to bplm of cos theta, 1 by root 2 into p00 of x. p00 of x is 1, so this is 1 by root 2. So the value of theta is 1 by root 2. Now for the pi equation, we have had the relation pi value is 1 divided by root pi into e power im pi. Here m is equal to 0, anything power 0, 1. So 1 divided by 2 pi. Now we have to multiply these two things. Psi 100, which is equal to 2 into z by a0 power 3 by 2 e power minus zr by a0 into 1 divided by 2 pi. Then theta value is 1 divided by root 2. Now we have to multiply this to provide the value of psi 100, ground state wave function. Now see here, psi 100 equal to root 2 into root 2, 2. Root 2 into root 2, 2, this 2 get cancelled. So 1 divided by root pi z by a0 power 3 by 2 e power minus zr by a0 is the value of ground state wave function. This is the value of psi 100. In the same manner, you may find out psi 200 and all other things. But the only condition is, in Laguerre polynomial, you have to use the summation. The value of k equal to 0 to n minus l minus 1. We have to use this condition. The k value, suppose n equal to 2, the possible values of k are, see here, k equal to 0, then n minus l. If you want to find out psi 200, here l equal to 0. Put n equal to 2, l equal to 0. Then automatically 2 minus 0 minus 1 is 1. So for k equal to 0, we have to find out the Laguerre polynomial, and for k equal to 1 also we have to find out the Laguerre polynomial. We have to make the sum of these two. Then we will find out the value of R20 of R. This is a simple logic we have to follow. In the Laguerre polynomial, we have to use the summation. Suppose n equal to 1, the value of k equal to 0 alone. Suppose the value of n equal to 2, for 200 state, we have to use k with two values. For k equal to 0, we have to find out, and for k equal to 1, we have to find out the Laguerre polynomial value, and then we have to make the sum up. to get the value of R20 of R. Finally, we arrive psi to 0, 0. So this is the value of ground state wave function of hydrogen atom. Then the spherical harmonics y 0, 0 of theta gamma pi includes theta equation and pi equation.